main goal is I can factor linear expressions, so we're going to be continuing working on expressions. And in a later lesson, we're going to be talking about why they're called linear expressions. We're not quite to equations yet. That's our next unit, so let's go ahead and get started. What is a factor? You guys have been working with factors since 3rd grade, and in 4th grade you guys learned how to find the factors of a number. So if I were to ask, what are the factors of 10? You would say that the factors of 10 are 1, 2, 5, and 10. And then if I asked you guys what the factors of 12 is, well, there are 6 factors for 12, okay? It's 1, 2, 3, 4, 6, and 12. You guys may recall a long time ago, you guys probably used something called a factor rainbow. Something that would tell you 1 and 10, multiply to 10, 2 and 5, multiply to 10, 1 and 12, multiply to 12, 2 and 6, 3 and 4. Those combinations get you 12. So, based off of that, I want you to pause the video and come up with your own definition for a factor. Okay? What does a factor mean in mathematics? A factor, as you might remember, is a number when multiplied by another number results in a specific number. Okay? If you have something close to this written down, that is perfectly fine. So a factor is associated with multiplication, and it's also associated with division. Okay? So when we factor in math, we're actually finding the factors of the expression. So we're no longer using just numbers, we're using algebraic expressions. So we're looking for things that was multiplied together, okay, to get that specific expression. Thus, we are undistributing. And I'll show you guys what that means in a moment. But first, we're going to do a little bit of review of 6th grade math. Last year, you guys did something called factor trees and tried to find the prime factorization of certain numbers. So, for example, the prime factorization, you might use the factor tree for 4 and did something like 2 and 2. That's a 2. 2 and 2. Okay. Like that. 12, you might have done 2, 2, and 3. And 16, you would find the prime factorization if you did the factor tree to be 2, 2, 2, and 2. Okay. So something like this. Okay. And then to find the greatest common factor, common meaning the factors that they have the same. So here 2 and 2 are factors, 2, 2, and 3 are factors, 2, 2, 2, and 2 are factors. Here we're trying to find which ones they have the same of, and they have the same of these 2's, these are all the same, and these 2's, these are the same. And we know that 2 times 2 gets us 4, so the greatest common factor for 4, 12, and 16 is 4. If we move on to the next question, it says find the greatest common factor of 12, 18, and 9. Again, we're going to find the prime factorization of 12, 18, and 9. And when we do that, we find that the 12 is 2 times 2 times 3. Remember that all of these numbers have to be prime numbers. So 4, 6, those are not prime numbers, so that's why we split them up even further. 18 has a prime factorization of 2 times 3 times 3, and 9 has a prime factorization of 3 times 3. And we can see from here that while 12 and 18 have 2 as a prime factor, and 9 doesn't have it, so that can't be common. What they do have in common is this 3 and only that 3. So therefore, the greatest common factor is 3. Alright, so go ahead and try this next one out on your own. Find the greatest common factor of 22, 8, and 28. The prime factorization of 22 is 2 times 11. 8, as we've already done before, is 2 times 2 times 2. And 28 is 2 times 2 times 7. Therefore, the greatest common factor is just this 2. That's the only factor they share. So the greatest common factor is 2. Go ahead and try to find the greatest common factor of 56, 16, and 24. So the greatest common, or the prime factorization of 56 is 2 times 2 times 2 times 7. 16 is 2 times 2 times 2 times 2 times 2. 24 is 2 times 2 times 2 times 3. So what they share, therefore, are these 2's right here. They share this 2, and this 2. And 2 times 2 times 2, as we know, is 8. So the greatest common factor of these numbers is 8. Okay. So what we're going to now do is factor linear expressions. So what that means is we're going to find two things that multiply together to get us this expression right here, 6x plus 10. Okay, and we're going to do that by factoring out the greatest common factor of 6 and 10. So we first have to find the greatest common factor of 6 and 10, and what that is 2. Okay, so what we're going to do is take out the number 2 from both of these. Okay, then the question becomes 2 times what gets us this 6x right here? Well, 2 times 3x gets us that 6x. So what we have here left in this binomial right here is this 3 right here, 3x. Okay, because 2 times 3x is 6x. Then we need to figure out 2 times what gets us 10. Well, 2 times 5 gets us 10. So therefore, our factored form, our two things that multiply together to get 6x plus 10, are 2 and 3x plus 5. Over here, we're going to do the same process, except we have something unique here. We have this coefficient right here is a negative number. This is very important. When a coefficient is negative, we have to factor out a negative number. So what I'm going to do first is I'm going to do, whenever we have a subtraction sign, I'm going to change that into addition of the opposite. So I'm going to rewrite this as negative 4x plus negative 10. Okay, negative 4x plus negative 10. And what we're going to do is factor out a negative number. So first, we need to figure out what negative number that is by finding the greatest common factor of 4 and 10. Okay. And that greatest common factor is 2. So what we're going to factor out is a negative 2 because we have a negative coefficient right here. So we're factoring out a negative 2. So the question becomes negative 2 times what gets us negative 4x? Well, negative 2 times 2 gets us negative 4x, so it's going to be 2x inside the binomial. Then negative 2 times what gets us negative 10? Well, that would be 5, so it's 2x plus 5 as our binomial. So the two things that multiply together to get negative 4x minus 10 are negative 2 times 2x plus 5. So our two factors are right here, negative 2, and the second factor is 2x plus 5. Okay. Notice how you can check your answers by distributing back in. If you distribute back in, you should get what you originally have. Okay, that's an easy way to check your answers. Okay, so let's take a look at number 3. Here we have a positive coefficient 2 and a positive 8, right, or negative 8 right here. So what we need to take out is a positive number because we have a positive coefficient right here. But first we're going to change this into 2x plus negative 8 to get rid of the negative sign. And then we're going to factor out the greatest common factor of 2 and 8, which is 2. So what we have is 2 times x plus negative 4, or 2 times x minus 4. Remember that these two things are the exact same thing. Adding a negative number is the same thing as subtracting a positive number. On this side over here, we have a negative coefficient, which means we're going to take out a negative number. So we're going to find the greatest common factor of 16 and 22, which is negative 2. We're going to factor out because we have a negative coefficient, leaving us with 8x minus 11. This question number 5 says that a rectangle has an area of 4x plus 6. The width is 2. What is the length? So what I'm going to do is draw this rectangle. Okay, and so draw a rectangle right here, just like that. And I'm going to split it into two parts. And I'm going to say that the first part has an area of 4x. And this part of it has an area of 6. Okay. That means that together, add together the area of both of these rectangles, add together gives the area of the entire rectangle, which is 4x plus 6. So this rectangle that I've drawn, this entire green box, has an area of 4x plus 6. We say that the width is 2. So I'm going to write a 2 out here. This length right here is now 2. This length right here. Okay. Now, to find the area, remember, is length times width. So if this box right here has an area of 4x and its length, or excuse me, its width is 2, it means its width right here, or the length right here, has to be 2x, because 2x, okay, 2x times 2 gets us the area of 4x. Over here, this has an area of 6, so this length right here has to be 3, because 3 times 2 gets us 6. So therefore, the length of this entire rectangle from here to here is 2x plus 3, because it's both the lengths combined. So the length for the entire thing is 2x plus 3. In this one, the rectangle has an area of 9x minus 12, so we're going to do the same thing. 9x minus 12, so this is going to have an area of 9x, and this has an area of negative 12. So the width, it says, is 3x minus 4, so I'm just going to change the width to this top part right here and say that this is a width of 3x, this is a width of negative 4. Okay. Therefore, in order to get that same area, we need to figure out what this has to be over here. Well, 3x times 3 gets us 9x, and then negative 4 times 3 gets us negative 12. So therefore, the length is 3. Okay, because essentially what we're doing is factoring out this 3 from this right here. Okay. So let's take a look at this again. Factor each expression. If the expression cannot be factored, write prime. Okay, very similar to when you try to find the factors of something like 5, right? We know that 5 is a prime number because the only factors here are 1 and 5. Sometimes we have expressions that do not share any common factors except for 1. So therefore, instead of writing down anything for that, we just call that a prime expression. Okay. So here, do a couple of them with you guys. 5x plus 10, the greatest common factor of that is 5. So what we have is 5 times 3x plus 2. Here, that's the wrong part right here. Here we have 7x minus 3. We can say that this is prime, and we know this is prime because 7 and 3 do not share any common factors. We'll skip down to number 4 since I already started it. What I'm first going to do is change the subtraction to addition of the opposite, and we have a positive coefficient. So therefore, we're going to look for the positive greatest common factor of 30 and 25, which is going to be 5. So when we factor out a 5, it takes us 5 times 6 gets us 30, and 5 times 5 gets us 25. So therefore, we have 5 times 6x minus 5. Over here, the greatest common factor of 6 and 9 is 3, so we're going to factor out a 3 right here, which gets us 2x plus 3. Number 5, 13 and 14 do not share any common factors, so therefore this one is prime. Here is our first example of a negative coefficient right here, so that means we're going to factor out a negative number. But first I'm going to rewrite this as negative 50x plus negative 75. The greatest common factor between 50 and 75 is 25. Okay? So we're going to factor out a negative 25, and negative 25 times 2 gets us negative 50. So therefore, we're going to have negative 25 2x plus 5. Okay? Go ahead and try out 7 and 8 on your own. The first thing we're going to do with 7 is rewrite it as negative 24x plus negative 18. We have a negative coefficient, so therefore we're going to factor out a negative, okay, which gets us, we're factoring out a negative 6, so negative 6 4x plus 3. Okay. Here, 18 and 13, 13 is a prime number, so therefore this thing is going to be prime right here. Go ahead and try out number 9 and number 10. Here, we're going to again rewrite it and then factor out a 4, getting us 4 times 4x minus 3. Here we have a negative coefficient, so therefore we're factoring out a negative 9, okay, and therefore negative 9 4x minus 5. Common mistake is to only factor out a 3. Make sure you're factoring out the greatest common factor. Yeah, the greatest common factor of this is 36. Of 36 and 45 is 9, so we're factoring out a negative 9. Here, number 11, a square picture frame has a perimeter of 20x plus 32. What is the length of one side of the picture frame? So here I have drawn a square, okay, and what we know is that squares have 4 equal sides. Okay? And so what we have to do is figure out what expressions, when added together 4 times, gets us this. Well, that's the same thing as division. Okay, so we're essentially dividing this 20x plus 32 by 4. So that means we're going to factor out a 4 from this expression. So 4, okay, and that means that, well, what do we multiply 4 by to get 20x? Well, that's 5x. And then what do we multiply 4 by to get 32? Well, that's 8. So each one of these over here is going to be 5x. Each side is going to be 5x plus 8, because each side has to be the same length. And if we add all of these perimeters together, okay, what we would get is back our entire perimeter of 20x plus 32. So each side of this is 5x plus 8. Here we have a rectangular with an total area of 4x plus 36, factor 4x plus 36. So again, we're going to find the greatest common factor and factor it out and make it this length, and then find out what we need over here as a result. So go ahead and try this one out on your own. The greatest common factor of 4x plus 36 is 4, okay, because 4 goes into 4 and 36, which means that this length right here, okay, is x, and this length right here, from here to here, is 9. So we have a length of x plus 9 and a width of 4. So in summary, if you had to describe factoring to someone, what operation would you relate it to and why? Okay. You'll see in your notes that the last 3 questions on the notes, we're not going to go over in this video, but what I want you to do is answer those 3 questions in a message. Send a message to me via Schoology. Okay, and answer those 3 questions and explain why you chose those operations for each one of those processes: factoring, distributing, and combining like terms. Okay, go ahead and do that. So just so that you know, I'm currently in Dayton, Ohio. I'm here visiting my brother. And right now, as you might know, it's during coronavirus time, and I was going to go visit my best friend from middle school as well. I've kept in touch with him, and we're still good friends. And unfortunately, he was supposed to visit me today. We were going to have some pizza and sit around and play some games. Unfortunately, his family got sick. I don't think it's coronavirus. He probably would have told me that. So he wasn't able to come today. I was hoping to get him in on the video. But maybe we can do that some other time. My best friend is Drew Quarter. Okay, my best friend from middle school is Drew Quarter. And so, if you've made it this far, in your message, as I write his name right here, C-U-R, Quarter, that's R, okay. So include this inside the message to me as well, and we'll see how many of you guys have actually got to the last part of the video. Stay safe, and hopefully I will get to see you guys soon.